All right, we're about to pull back the curtain on a piece of technology that pretty much powers our entire digital world, the database. And we're going to explore how it really works using a simple, but honestly super powerful analogy, the super librarian. I mean, have you ever really stopped to think about it? Every single photo you've posted, every message you've ever sent, that one thing you saved in an online shopping cart like 3 weeks ago, how does all of that just stick around? How is all that information managed? Well, the short answer is the database. And believe it or not, the best way to understand how it works isn't with a bunch of complex code, but by imagining this librarian, a total master organizer who can store, find, and protect billions of pieces of information without ever breaking a sweat. So, to really get how this all works, let's start with the first big problem any database has to solve: speed. How in the world does it handle millions of requests without just grinding to a halt? The secret lies in the difference between our librarian's desk and the stacks. Okay, so our librarian really has two main work areas. You've got the stacks. Think of this like your computer's hard drive. It's absolutely massive, and it holds everything permanently, but it's kind of slow to get things from. It's a long walk down the aisles. But then there's the desk. This is like a computer's memory or RAM. It's much smaller, yeah, but anything on it can be grabbed in an instant. It's blazing fast. And here's the really clever part. Instead of running back to the stacks for every single little request, our super librarian keeps the most popular stuff, the most frequently used information, right there on the desk. In the tech world, this is called caching, and it is pretty much the #1 reason modern apps and websites feel so snappy and responsive. Okay, so we're fast. That's great. But what happens when you need to find one specific book among billions? This brings us to the next secret weapon in our librarian's arsenal, the magic card catalog. And this is not a small problem. If you asked for just one specific piece of data, like, say, your own user profile, how does the system avoid searching through every single user profile on the entire platform just to find yours? That would take forever. Without a good system, the only option is what engineers call a full scan. You can just picture it. Our poor librarian would have to walk down every aisle, looking at every single book on every single shelf until they finally found the one they were looking for. I mean, it's thorough, sure, but it is incredibly slow and inefficient. But with a card catalog, the librarian doesn't have to wander around at all. They just look up the title, get the exact location, aisle 7, shelf 3, book 5, and they go directly there. It's a targeted, lightning-fast operation. Now, this card catalog has a technical name, an index. It's a separate, highly organized list that doesn't hold the data itself. Nope. It simply points to where the real data lives. And this one simple concept is the secret to fast searching in just about every database on the planet. So speed and searching are great, but what about safety? Your data is precious. How does a database make sure your information is never, ever lost or corrupted, even if everything goes wrong? Well, this is where the librarian's safety net comes in. Just imagine the librarian is right in the middle of updating a record, maybe changing a book status from available to checked out, and suddenly, bam, the power goes out. How do you stop that record from being left in some corrupted, half-finished state? Here's how they do it. Before touching anything on the main shelves, our librarian first writes down exactly what they're about to do in a separate private logbook. Something like, I am about to check out book XYZ. And only after it's written in the log do they make the actual change. That way, if the power goes out, they can just look at the logbook when it comes back on to see what they were doing and either finish the job or undo it safely. This safety log is what guarantees reliability. It makes sure no update is ever lost or left half done. This simple mechanism is why you can trust that when you hit save, your stuff is actually saved for good. All right, on to our final big idea. Sometimes a single task involves multiple different steps. So how does the librarian make sure these complex jobs are handled perfectly every time? Well, it all comes down to the all or nothing rule. In the tech world, this is known as a transaction. Just think of it like a wrapper or a bubble around a whole set of actions. The database makes a promise. Either every single action inside this bubble completes successfully, or none of them do. The system just rolls back to exactly how it was before you even started. And it makes perfect sense when you think about it. You can't just take a book from the shelf without also updating the checkout list, right? Those are two separate steps, but they have to happen together. You can't have one without the other. Transactions enforce this all-or-nothing rule, and that's absolutely critical for things like, say, financial transfers or managing inventory. So there you have it. This is the Super Librarian's entire toolkit. It's not one single magic trick, but a combination of all these clever, interconnected systems. A fast desk for caching, organized stacks for storage, a magic card catalog for indexing, a safety log for reliability, and those all-or-nothing rules to keep everything consistent. And that's really the big takeaway here. These principles, which are elegantly simple when you think about them through our librarian analogy, are the absolute bedrock that allows for the complexity and reliability of the entire digital world we use every single day. So that leaves us with one final thought to chew on. Our super librarian system is built for neatly organized shelves and card catalogs. But as data becomes more and more chaotic, we're talking videos, social media posts, all kinds of unstructured documents, what will the library and the librarian of the future really look like?